All right, guys, two more examples with the AC method just because I think it's so cool. All right, so we're going to start with 3x squared plus 4x minus 7 plus 4x minus 7, and I am going to pause to copy the problem down. All right, so we know 3x squared is our leading term. We know negative 7 is our y-intercept, and we are looking desperately for these numbers. All right, so AC method. I'm going to look at A, which is 3, and C, which is negative 7. Their product is negative 21. So I'm looking for two numbers whose product is negative 21 and whose sum is 4. And just by curiosity, I tried 3 and negative 7, but their sum is negative 4. So after digging a little bit, I actually just have to reverse those. All right, the two numbers whose product is negative 21 and sum is 4 would be negative 3 and positive 7. All right, so that means now the cool thing is you can put your negative 3x and your 7x in whichever one. It'll work whichever way. All right, so I'm just going to put a negative 3x here. All right, because you have found the numbers that give you the diagonal sum, and a 7x right here. Next, I try to find a number that'll multiply to both of these. Okay, so here I go. What number could I multiply another number by to get 3 and 7? Well, that's just 1, right? But to get an x on both of these, I just need an x. So that's 1x. Same right here. If that's a 1x, then right here I need a 3x, okay? To get 3x to multiply to be negative 3x, I'm going to need to have a negative 1 there. And then it's like working backwards. To get negative 1 to multiply to negative 7, then I have to have a positive 7 right here, which checks out for the 7x as well. So it's kind of like working a backwards puzzle. So our answer is 3x plus 7 times x minus 1. All right. All right, so the second example, I've got 3x squared minus 14x plus 15. So we jumped real quick to a second example. 3x squared minus 14x plus 15. I'm going to use AC again because, again, I could just guess and I would end up finding it, but I'm going to use AC. So A is 3 and, I'm still on the Zoom. A is 3 and C is 15. All right, so 3 times 15 is 45. And sum of this, let's see, the sum has to be negative 14. All right, so to get this to work out, two numbers whose product is 45 add up to negative 14. Well, they both have to be negative. The two numbers actually are negative 9 and negative 5. Try it out. Their product is 45. Their sum is negative 14. All right. Then put them wherever you want. Negative 9, I'm going to put a negative 9x right here, and a negative 5x right here. Now it's like finding their greatest common factor. That's basically what you're finding, right? I see a 3 and a 9, so it's easy for me to spot that one. I know that's going to be a 3x, which makes this guy an x. And if this guy an x, if that guy is x, then that means this has got to be negative 5. If this is a negative 5, then to multiply to be positive 15, I'm going to need a negative 3. All right, so x minus 3 times 3x, or x minus 3 times 3x minus 5. So you can see how it works out. And again, I encourage you to take the original one and graph your final expression. If they're the same graph, then you have factored correctly. So you should really never miss one of these problems because you will know if you have factored it correctly or not before entering it into Delta Math. Okay, so that is how this works. I hope that the AC method has not been too difficult. All right, once again, it is simply the product of two numbers is AC and their sum is B. That is actually the same thing that we did whenever we first learned how to factor. All right. Because in that case, AC, we just called it C because A was always 1. All right. But it's really the exact same process, and it helps you right here with your box method.